everybody, it's Mrs. Casil from Northurston High School, STEM Physics. I want to show you the Conservation of Momentum Analytical Lab. So for this lab you need a ball. I do not have a golf ball. I'm using one of my kids' balls from their toys. You need a cup. I'm actually going to use 2 cups and I'll show you why in a second. For my ramp I used something super fancy. I used a cutting board, a book, and then to keep it from slipping on the table I literally took a rubber band, 2 rubber bands actually, and I just put one underneath the edge right here where it's resting on the table, and the other one up here where the cutting board's resting on my book, and now it doesn't slide. So that's my non-slip solution here. I've got a measuring tape that I'm using to measure the distance along the table, and I'm going to be using coins. My daughter was playing with these also. Coins as masses to change the mass of one of the objects in this setup. Ooh, I also need to know the angle of my ramp, so I'm using my phone to use the level on my phone to measure the angle. This is a 8-degree angle. All right, there we go. So I'm going to put my 2 cups together and set them up down here at the bottom. The big idea of this lab is we're going to have an inelastic collision. I'm going to have this ball roll down the ramp. Because it's rolling, it obviously has momentum, right? It's got mass, it has velocity. So while it's rolling down the ramp, it has momentum. When it gets to the bottom, if I were to let it go, it also continues to have that momentum even after it leaves the ramp. These cups, however, sitting at the bottom, have no momentum. They might have mass, but they've got no velocity. However, if my ball rolls into the cups, they slide off together because they have experienced an inelastic collision. Their masses have combined, and how much momentum they have is a product of what mass they have together and what velocity they have. Okay, Elaine. That's my daughter, Elaine. She's my lab assistant. So what you're going to do is you want to show how much momentum there is after this collision and how much momentum there is before the collision, right? So your job is to learn how to do this experiment properly, and welcome to the world of doing science at home. You're going to try stuff and it's not going to work great, and then you're going to have to grab your materials and try different things. You've got a big brain in your head. It's okay if you try it a couple times. Just delete the ones that don't make sense when you're like, wow, my cup rolled off the table. Okay, no problem. That's the reality of doing science in the real world. So you're going to be letting the ball roll down the ramp, and you can assist it a little bit, or you could put some tape or stack up another book to kind of create a track for your cup so that it doesn't roll. That would be a great solution. And you're gonna see how far does your cup go. So right there, it went about 5.5 inches. Inches is not a metric unit, so I'm gonna convert those into centimeters once I work on my lab calculations. All right, what we're gonna do next, after you've collected data for that part, we want to make this heavier. In your lab instructions, it tells you to tape coins on top of the cup. Even in the classroom, that doesn't work for real. So this is why I have 2 cups. This is how we do it together in class. I'm gonna put quarters or coins. I grabbed the change jar out of the junk drawer. I'm gonna put them in the bottom of 1 cup and then put my empty cup on top. Great idea, Elaine. And now I'm going to put this cup right here. It's now a heavy cup. It's got coins in the bottom of it. So the empty cup that's on top of it holds those coins in place so that way they're not slipping and they don't really change how much the cup is going to roll. So I'm going to let my ball roll down, and now you'll notice it didn't slide as far. Surprise, surprise, it only slid about 3 inches. I'm going to just demonstrate that this really does work. I'm going to put even more quarters in there. And bloop, bloop, bloop. Ooh, only went less than 2 inches that time. So that's the idea in this lab. You're going to increase the mass of the cup. You're going to measure how far they go and use that as a model to show that there's a change in what? Well, you have to think about what is changing. I've changed the mass here, but the momentum is the same before the collision because I'm letting the ball go from the same position each time, right? This collision has the same momentum before the collision because the ball has the same mass, the same velocity when it collides with the cup. So can you collect data that explains why it doesn't slide as far as we add mass to the cup? Right? Be creative with your materials. Ask your science teacher if you need help or you need ideas. But this is hopefully enough to give you some good ideas to get started. And good luck with the lab, everybody. All right? Have fun. Bye.